Hey there, so this is the Spring 2022 Physics Extra Credit number 2 for 3A. This is kinematic equations for projectile motion. The horizontal component has its equations in orange, and the vertical component has its equations in red. These both assume that the acceleration in the vertical direction is equal to 0, and gravity is negative 9.8 meters per second squared. If an object is released from a reference angle of theta, the horizontal component of the velocity is initial velocity times cosine of theta, and the vertical component of velocity is initial velocity times sine of theta. So now let's take a look at our example problem. A ball is thrown at 22 degrees from the horizontal from an 8-meter platform, and the initial velocity at which it is thrown is 40 meters per second. So using the equations detailed above, once again, here they are in pink. The horizontal component of the velocity is 40 meters per second times cosine of 22, which is 37.1 meters per second. And the vertical component of the velocity is 40 meters per second times sine of 22, which is 15 meters per second. So for problem A, we have to figure out the time that the ball spends in the air. In doing so, you use the y equals y naught plus initial velocity times t minus 1/2 gt squared. We do so, and we plug in the final y as 0, the initial y as the height of the platform, 8, and the initial velocity, which was solved, it's highlighted, and everything else is just 1/2 gt squared, which is negative 4.9 t squared. Then we just plug it into the quadratic formula, and we find out the time is equal to 3.52 seconds. This is the amount of time the ball spends in the air. Now for B, we're looking at the vertical distance covered by the ball. In doing so, we use the final distance of x is equal to initial distance of x plus the velocity of x times t. So we use the x component of the velocity, so the horizontal velocity, which was once again 37.1 meters per second. We plug that in and multiply it by the time that we figured out the ball spent in the air, 3.52 seconds, and then we get x equal to 131 meters. This is the vertical distance covered. Finally, for problem C, we're trying to figure out the final velocity of the ball when it hits the ground. The velocity in the x component, the horizontal velocity, will remain the same, 37.1 meters per second. The y component is the initial velocity minus the gravity times the time spent in the air, which is negative 19.4 meters per second. Then we just take the square root of the horizontal squared plus the vertical squared and get 41.9 meters per second as your V final. Thank you. I'm Siddhant, and I did this with Oshini.